Welcome everyone to the last segment of our summer speaker series. I'm so excited to have Dr. Mazin with us today to share about the topic of biomechanics and its impact on scientific research and the medical industry. And before we get started introducing him, I'd like to introduce myself. My name is Sandra Cannon, and I am the Assistant Director of the Institute for Private Training. And here at the Institute, we offer customized courses that companies can hire us to provide training for a wide variety of things, whether it be cybersecurity to health and safety, whatever training needs you might desire for your employees to upskill. We have a very highly educated faculty and staff who can provide tailor-made training for employees. If you're interested in anything like that, you can visit our website at aiu.edu.kw/IPT, and there's a form there for a free consultation to learn more about those options. So without further ado, I would like to introduce Dr. Mazin. He is an assistant professor and program coordinator in biomedical engineering here at AIU. He has his bachelor's degree in biomedical engineering from the University of Medical Sciences and Technology in Sudan, and a master's in biomedical engineering and a PhD in cardiovascular biomechanics from the University of Cape Town in South Africa. He has held the visiting researcher position in tissue bioengineering, the Tissue Bioengineering Laboratory at Mississippi State University in the United States. He is an was an honorary research associate for the Department of Biomedical Engineering at the University of Cape Town in South Africa, and the Isolomso, I apologize if I'm saying that wrong, Fellowship Award winner for early career African researchers by the Stellenbosch Institute for Advanced Study in South Africa. And he's also an ad hoc reviewer of multiple international journals. Some of his research interests and experience are in soft and hard tissue biomechanics, computational modeling, biomechanics of prosthetics and implants, and he has publications in 12 published peer-reviewed articles. And we are so excited for his wealth of knowledge in this area. And I know next to nothing about biomechanics, so I'm so enthusiastic to learn more about the scientific research and how it impacts the medical industry. So Dr. Mazin will now have the time to speak for 30-ish minutes, and then we'll open up time for questioning. If you have questions at the end, we are happy to have you. Thank you, Dr. Mazin.
Thank you very much, Ms. Sandra. Thank you very much for this opportunity. Good afternoon, everybody. Whoever's watching this, it's really a pleasure to be here. And I would like to welcome you all to this session. And I hope by the end of the session today that we will be able to get a little bit of information about biomechanics and its impact on research and industry, in particular medical industry. So this session today, I would like to address 5 main things. First of all, I would like just to give a general definition of the biomechanics so that we all know what is biomechanics, with the biomedical engineering being relatively a new area of study here in Kuwait. Biomechanics is even more mysterious, I believe. So it's my job to highlight a little bit about that. And then I would like also to highlight the branches or the fields or the subfields of the biomechanics. Then we'll talk about the research areas and how biomechanics could help in medical industry. And then we'll try to briefly look into challenges and also opportunities and their available resources here in Kuwait. So what is biomechanics? Biomechanics, if you look at the term, it's biomechanics. So it refers to biology and mechanics. There are so many definitions, but the one definition which I always like is defining the biomechanics as a multidisciplinary science concerned with the application of mechanical principles to conception, design, development, and analysis of equipment and system in biology and medicine. So we would like to utilize what people in the mechanics or mechanical engineering or mechanical sciences have developed to some sort of address issues in biology and medicine. So with that in mind, we would like to also try to understand what is the meaning of mechanics. So mechanics simply when we have forces applied to any solid subject. For instance, we have two either of scenarios that could happen. Either that solid subject is going to move, in which we are going to have motion, or it's going to have undergo some changes in the shape, or what we call it deformation. So this is basically the foundation of mechanics. It's basically when we have force applied to a solid subject, that subject is either going to move or it's going to deform. Based on these two scenarios, the field of applied mechanics have been divided into three main categories. So the first one is called the rigid body mechanics. I don't want to get into details, but just to give you the general idea. So the rigid body mechanics, that's basically the motion.
Dr. Mazin, I'm so sorry to interrupt you.
Sure.
We are seeing something on the screen that says, please move this window away from the shared application.
Okay.
I'm not sure. I've never seen that before, so I'm not sure what's causing that.
Okay. Let me just see.
It's just a sign that keeps popping up on.
Okay, let me just stop sharing and let me do that. Thank you very much for. I'm also seeing it, but I thought it's only on my side, but let's see. You don't see it now, right?
No.
Fantastic.
Perfect.
So we can.
Great. Thank you.
Thank you very much. So we have the rigid, what we call rigid body mechanics, and that's simply the motion. And we have the deformable body mechanics, and that's defines the second scenario of deformation. So why do we have these two branches? The applied mechanics or the mechanical engineering experts, they say that, okay, whenever we have this force applied into an object, we have these two scenarios, but we cannot study both of them together. So that's why they have been separated. So following this two categories, and of course, the first two categories, the motion and deformation, mainly for solids. That's why we have a third branch, which is called fluid mechanics. So these three branches, they simply define what we also see in biomechanics, but because remember, it's mechanics applied in biology and medicine. So if we are going to apply the rigid body mechanics, the deformable body mechanics, and also fluid mechanics to address things in biology and medicine, it's as simple as that. So what are the branches of biomechanics? There are so many. There are so many branches, literally in any field or subfield in medicine, biology. And things like sports, dentistry, cell mechanics, in orthopedics, soft tissues, hard tissues, ergonomic, forensics, rehabilitation. So there are endless applications. Why is that? Because any or each of these fields, they're going to either include the need to understand what forces are going to happen, what forces are going to induce, what is going to happen when we have that amount of impact hitting this body, or how fast that part is going to travel. That sort of questions, these are all we can find these in any of these branches. That's why if we want to look, for example, at rigid body mechanics, remember it's about motion. So we'll see this in motion analysis, kinesiology, in sports, in even rehabilitation, some computation. So rigid body mechanics is used in analysis of human movement, and this is a very essential part of how we utilize the rigid body mechanics principles to understand how different segments of the body work. And this happens through basically taking some visual markers, and we put them into the body subject, or in the body of a subject, and then using some laboratory settings where we have cameras everywhere. These markers are reflective markers where we can capture the movement of these markers to basically identify how different segments of the body can move, or can move in 3D space. And with even more information about how the forces on the ground could be generated, how the muscles actually related into that motion with the muscle interaction. Together, when we gather all these information, we can either help an athlete to improve their performance, or a patient, for example, who would like to restore a normal motion, or simply suffers from an accident or from a specific injury or abnormality in the joints or things like that. So this information helpful very much to prevent injuries, to improve performance in athletes, but also for patients to help them restore as much as they can, or as much as possible, from their normal motion or walking pattern. So such information, we can then use specific some software to help us gather information about how actually the body works. So a specific motion like this subject jumping on a single foot, what are the muscles that are actually involved in such motion? This information can then help us maybe focus on specific muscles to improve or increase the strength of those muscles. Or how can we improve the balance? How can we improve the general performance of that subject? So this is the rigid body mechanics. So when we move to the deformable body mechanics, we're here not interested into motion, but basically how the subject or the material from which the subject is made, how it behaves. For example, if I look at this bottle of water, I'm pretty much sure that if I squeeze, it's going to deform, right? But nevertheless, if I put 10 bottles on top of this bottle, it's not going to collapse. So there are some things that we need to understand about the material of this bottle. Similarly, when we talk about the bones, the muscles, the heart, the lungs, these are all tissues that some sort of made of some sort of biomaterials or materials that we would like to understand, to either understand specific injuries like what I'm going to show you shortly, or maybe developing proper treatment, or as I said, even prevent injuries. So deformable body mechanics, mainly about the mechanical properties of materials. For example, we could use some information about the bones, how the bone, what is the mechanical properties of the bone. Things like what you can see here. I don't want to get into details, but this is basically, we're looking at the knee joint, and here we have a very essential soft tissue called the cruciate ligament. And with some experiments, we found that, our research found that depending on the speed by which these ligaments are torn or are pulled, the mechanical performance, mechanical behavior of that material changes. And this actually helped the medical field, or in orthopedics, or in sports injuries, to understand why such injuries, things like hip fracture in elder people, why hip fracture, why it's more often happens in elder people compared to young generation. So why? Also, the sprain injury in ankle. This is very common, although any one of us can actually pull their ankle to such critical angle, yet no injuries is going to happen. But you're walking normally on the street and that thing happens quickly, it immediately triggers the injury, because the speed of the force was a little bit different here. So understanding these issues will help us to prevent these injuries or to think of a proper treatment to these conditions. That's why it's not always about the biological tissues or the biological material like bone or muscles or tendons. It helped us also develop synthetic materials that could help us replace or support specific organs or parts of the organs within the body. Things like in dentistry, in orthopedics, this is a stent where they can be used to support grafts or even to support the arteries. It's mainly made of metals or ceramics or polymers, but understanding the mechanical properties of these materials, synthetic materials, could help basically improve. That's all thanks to the understanding of the deformable body mechanics. The only difference here is that these materials, because we use them inside the human body, they have to have what we call biocompatibility. So it's not like any metal we can use. No, beside their mechanical properties, we want to make sure that these materials are body friendly. So they're not going to cause problems when they are inserted inside the human body. I'd like also to highlight what is called computational biomechanics. Mainly the computational biomechanics or the computational mechanics in generally, there are two branches, what we call finite element modeling or methods, mainly considering the solid structures, or the computational fluid dynamics, where the fluid mechanics are studied. These are also used widely in so many structural mechanics or fluid problems. Things like just we would like to use some softwares with some equations to help us predict how a specific object is going to behave under specific loading conditions. This could be a pipe or any object where we have this force applied here. This is also a beam which was subjected to specific force. We specify the materials, things like that. We can predict how it's going to behave. This tool is very important in in research, but also in industry. Some sophisticated things could in normal mechanics, things like studying the crash of a helicopter or a plane when it hits an imaginary object, how that could help actually improve the design of that helicopter. So we can use the same concept like also in computational fluid mechanics to see how the air is going to flow on an airplane or maybe inside a pipe. So this is in general mechanics, but what would happen if we would like to apply this in biomechanics? Such tools could help us understand things like why we have these vertebral fractures in elder people, why, and how the osteoporosis, a condition that happens to elder people, how it's actually affecting that injury, that the computer simulations can help, computational mechanics can help us address that. Things like how would the blood flow in the artery. It helps in understanding a lot of abnormal conditions or diseases that are mainly related to the flow of the blood. And that could induce or understanding the mechanical property, let's call it the mechanical circumstances of such a situation can help us either develop a treatment or prevent a condition. Things like this one, I really like it. Basically, biomechanics of biting. So what could happen? Let's assume that this is a gum or a piece of bread or whatever. So how the deformation, how it's going to behave, how that's actually going to affect the teeth. This is all computational mechanics, or even things more sophisticated like a valve, any valve within the heart, how it's actually going to behave, whether it's a normal valve or maybe an artificial one. Would like to test it to see how it's going to behave. under specific mechanical conditions. So we have talked about the branches biomechanics, and now if you look at the research areas, any of these branches could actually have, or definitely have some or a lot of research that going on to address a lot of problems involved. I'm just going to highlight some research from different areas to give you an idea. Things like orthodontics. We all aware of orthodontics, but we never asked how actually these wires are actually designed, on what purpose, and what is the effect of these metal wires that the dentists use to put what actually, how much forces they are actually induced in these teeth, what angle. All these information, computational mechanics can help, like in this study. Or as we said, what happens to issues like osteoporotic vertebrae, like vertebrae that have low concentration of bone. What is going to be the effect, how the compression is going to be burned, how the mechanical or how the other vertebrae is going to behave. And if they're going to behave abnormally, how can we intervene to somehow support that, to bring the level of stresses to a normal, back to a normal levels, or things like that. So these are all researches. And one of the also very advancing research these days, it's about the injury, how to prevent the injury, how the injury happens. Things like when we have car accidents, the main issue is the brain injuries. So nowadays, this is also even used in forensics. They have camera videos from the accident. They try to use computer simulations to try to imitate the scenario of the accident, how the subject, in what angle, what is the speed of the car, and then try to build computational models where they can see the amount of what we call it, the impact on the brain. So how tough the hit was. And depending on these computational models, we can predict what is the possible injury. When we say injury, it could be the fracture on the skull, or even the damage on the brain inside. And that could happen through an understanding of how the accident actually happens and the different layers of the brain. These are all computational biomechanics problems. This could be used in designing safety issues, just like safety, like helmets, or even the car designs, or even perhaps investigating post-mortem conditions, like in forensics or things like this. Is a very big area. Okay, so it's not only about the brain and the big organs. It can actually, we can go down to even the cells. How does the cells work under forces? What happens when we apply forces to cells? How they're going to move? And this helps to answer a lot of questions in things like cancer cells, or it's all about mechanics, because one of the questions that scientists have been trying to answer, what happened? I mean, we have a cancer cell in area and it somehow moved to another area. So how does this happen? When we say move, that's motion. So they started to understand that cells actually somehow interact to the surrounding environment, including the mechanical environment. So how much forces these cells can sense, the reaction of those cells can depend on these info. And this is also a very big area called cell mechanics, or mechanobiology. Right. So now because of the time, I'm not going to be able to present examples from all, but I hope what I have showed you so far is enough to give you a little bit of better picture about what is happening in the research area by biomechanics. Now, let's talk about the medical industry. I pulled this graph yesterday from this this website. And this shows you the North American medical device market size from 2018 to 2029. Some of you might ask, oh, but we're still in 2022. So, but what they do actually, they take the values up to 2021 and then somehow extrapolate or try to predict what happens or how the trend goes in until 2029. And someone can easily say that since we have in last year 2021 the North American medical device market invested like 188 US billion or 188 billion US dollars. So in 10 years that number is possibly going to be double, and that's actually normal because we have an increase in populations and also we have increase in technologies. So that means in terms of market there is a demand. And when we say market, I'm not going to speak here about the medical industry in general, but just a little focus on the biomechanics related industry. So things like shoe insoles or things like braces for foot abnormalities or fractures, things like that, or preventive wears like helmets, or even more complicated or advanced devices like dental implants, orthopedic implants, cardiovascular implants. So the question is, can we actually develop these? Can we manufacture these? Of course we can, but that requires some sort of factors or conditions. I just want to show you some of the research that could happen in using the same finite element models to predict how the design of the helmet, if we mix different materials, how the response of that helmet when it's been hit by an object, depending on changing or playing with the material that help us in optimizing what would be the best design in terms to gain the maximum prevention or the maximum protection for the subject. Things like shoe insole. These could easily be designed and also investigated depending on the material and also the impact of the foot. And guess what? Biomechanics is also very popular in fashion design. So things like the high heels shoes, how can we design them so that they are acceptable, but also they are healthier? And studies have shown that actually increasing that heel might affect what is happening in the toes. So it's not healthy in the long run. So how can we actually prevent that? What can we induce into the design of these shoes in order to prevent that adverse effect? Things like the mattresses in the hospitals. Patients normally lie there for maybe days or sometimes months. What can we do in the design of these mattresses to prevent like unwanted side effects like back ulcers or things like so? What is there a way to play with these? Yes, and it's really open areas. So these are all simple issues that that the industry can start to invest. And depending on the complexity of these devices, one can go from low risk devices to even high risk, but that involves some sort of additional required factors to pay attention. Anyway, so biomechanics in Kuwait, what are the challenges and what are the opportunities? Challenges, first of all, education and training. And that's where comes the things like the institute here at AIU for continuing education. It helps provide the required education training to those who actually seek to gain the required expertise in order to work on these areas, or maybe to develop their own designs or even develop their own company. The challenges are also limited number of local expertise, and that, thanks to internet, thanks to online work, it's not as big problem as it used to be. So, but again, it's still a challenge, but it could be addressed. Also, the public awareness and interest. It's sometimes especially in areas where biomedical engineering, biomechanics is used, very difficult to convince people, but that actually comes with time. So biomedical engineering as a field, as an area of study or education or expertise, it's relatively new here, but with time, the awareness is going to increase. The interest of the investors could actually also increase when they see that how like the financial or economical impact and all sort of that thing. So when they see that the other challenges have been addressed, like the education train, we have trained people, they're ready to do the job, the interest might increase. And also the resources. And when I say resources is a summary of all these things. So the education, training, the development or the build up of the capacity required, like the human capacity, the equipment, the training, expertise, things like that. These are all challenges. But also when it comes to opportunities, I think taking that route, it's an opportunity, because when you have sometimes when there are no people, it's a challenge, but also it's an opportunity. So the demand for human capacity development, the great impact on quality of research. We would love to see research, biomechanics research, impacting health decision makers here in Kuwait in maybe 5 or 10 years from now. Clinical applications and direct impact on healthcare. So it's not only about research, but also in the healthcare service. So we would like to see biomechanists working in clinics beside the other team members in rehabilitation, for example, in order to support the work of healthcare providers. Also, promotion of local manufacturing, and this fits very well with the resources that are available here in Kuwait. So it's true that resources could be challenged on one side, but I believe it's also an opportunity on the other side. And to also meet with the vision of the Kuwait 2030 or 35, the sustainability is also a very, very important. Why would we go to import such products where we can actually have them here produced inside Kuwait? And this what we all hope to see in from now, maybe within the next 10 years. Thank you very much all for listening, and I hope the time was did I do well?
Yes, yeah, you did well. You are right on time. Thank you so much, Dr. Mazin. That was so fascinating.
Thank you.
I had to laugh at the high heel slide because I've yet to find a shoe that's high heels that is comfortable for me. So just thinking about the different applications of this is incredible. I just loved all the examples that you gave. It was very interesting. We'll open up the time now to questions. So if you have any questions, you can put them in the chat, or you can unmute yourself and ask those questions. that time is now yours for that. There's always a little quiet moment before people are brave enough to ask a question.
Or maybe the presentation was so clear that nobody wants to ask. So that means I did a good job.
Yep. I have a question. You mentioned this is fairly new in Kuwait, this idea of using biomechanics, and we're the first university to have this department in Kuwait, correct? And this degree, medical engineering. So can you explain a little bit, if you can? I know this is kind of like a broad topic, but you mentioned some of the limitations and things like that, but what is being applied now in Kuwait in these different areas that you talked about? Is there anything yet really happening in this industry? What aspects are being applied in Kuwait specifically?
Okay, so in terms of biomedical engineering in general, the main focus at the moment for those who work in hospitals to look after the machines or the equipment that you use in hospital. But I know that there might be some research, but it's like all self-initiatives, like maybe a professor here or a professor there who are interested, who have been already working in these topics during their doctoral degrees or postdoctoral fellowships. So they moved back to Kuwait and they started to continue, but they are all isolated things. But my main concern is that these research should come from let's say like a solid collaboration between the healthcare providers and also the government and the universities or research institutes. It's things like coordinating the work in order to address specific issues. Unfortunately, I have been here now in Kuwait for 2 years, so I might not be fully aware of what's happening, but I believe that there is much to be done in that area.
Well, that's exciting for our students then who are going to be graduating with this degree, the applications they'll be able to bring to Kuwait. We had a question in the chat. They said, Vishal says, what is the scope of nanobiotechnology?
Wow, that is a very interesting question. So nanotechnology have been everywhere, and nanobiotechnology is the future of medicine, beside other things. But in terms of the nanobiotechnology, I'm going to speak about the scope here within Kuwait. As I said, things comes with expertise. Like if I would like today to work on nanobiotechnology, it's possible, but I'll start to see outcomes maybe 5-6 years from today, because it's a highly multidisciplinary area. It's not only about biomechanics, but involves a lot of biology, a lot of material science. I personally worked in some research initiatives that, to address regeneration of organs, and things like regenerating skin, regenerating the heart, which is the one of the most difficult areas that we're working on. But also, I was involved in creating what is called the scaffolds. These are the mechanical structures that provide support to the regeneration or the regenerated organs. I know that biotechnology or nanobiotechnology is also a lot of other applications, but as I said, the question for us is always how the force or the mechanics is involved. Whenever it's involved, either in, as I said, the environment that supports the regeneration, or maybe the flow of some cells, like what we call the cells motility, or the motion of the cells. This also, I know that a lot of people, but the question is, do we have the required expertise? And I personally always tend to prefer start with the simple things and then build and go to more complex, rather to jump into the top complex things, and then you get stuck, and then the question is where we can move from there. So I hope that answers the question. Thank you very much.
Thank you. Very interesting. Any other questions before we end the event? Okay, well, thank you so much, Dr. Mazin. This was such a treat, very enjoyable, and I learned a lot from your presentation. Thank you for joining us. And again, if anyone has any interest in hiring us for a training in biomechanics or any other field, you can visit our website at aiu.edu.kw/IPT and fill out the form there to get in touch. Thank you.
Thank you very much.